All right, so what does it take to make a custom line style? Well, a custom line style can be created from a number of different component types. A stroke, for instance, is typically required for just about every custom line style you create because it tells it how to repeat itself. How does it repeat the interval of the posts over and over and over again, or whatever it is that you're generating? If you're going to do 3D geometry, that's going to be a point symbol, folks, a point. You can also incorporate internal line codes into a custom line style, although for something like we're doing for 3D right now, that doesn't make a lot of sense. You can also incorporate raster components. I didn't list that here because, again, that's not really part of something that we're doing, but you can also incorporate raster components and create raster line styles if you wish to. Now, if you have multiple pieces that you need to put down at once, if you have multiple points, for instance, multiple cells that you need to incorporate, you're going to require a compound to tie the multiple pieces together. Now, I think all this will make sense as we go ahead and configure one of the custom line styles. And then, folks, you also give one a name as well. You give it a name that's more of the user-friendly name that the person picks from the line style selection when they're ready to use it. Again, if you have questions about this, look at some examples of some existing custom line styles, either the ones that come from Bentley within the software delivery itself. And for those of you that are using something like OpenRoads Designer Connect Edition, there are a number of 3D examples that are delivered with the software. You can go take a look at them, look at the RSC files, and see how they're put together. All right, now we're going to build a line style over here inside of MicroStation. Now, when we do this, there's a couple of things for us to essentially keep in mind. Again, orientation is a big thing. So I'm going to go ahead and rotate this back over to a top display. So we're looking straight down on the barrier. And as you can see, I didn't get my dimensions right. I must have did the math incorrectly in my head, but that's okay. We're just going to go with it here today. Now, as we start this process, we begin by going to the custom line style editor. And there's several ways to get to this. My favorite way is just simply through the line style pick that we see here in attributes and selecting manage. Now, when we do so, this opens up your line style editor. And honestly, folks, other than a couple of new things, minor things that were added in, the line style editor still works the same way that it has for years and years. All right, so how do we begin this process? And the starting point for this is where we edit line style definitions. We have to do this through an RSC, a resource library. And so from here, you can either add your new line style definition that you're trying to create to an existing resource library, or you can create a brand new one. If I use RSC files to edit, but DGN libraries to deliver, I like to keep them separated out. So I do a separate RSC file for every line style definition. To me, it just makes it easier. It's cleaner, but you can do what you want here. Now, today, I'm going to go ahead and create a new RSC file. And we just simply are going to put this in a configured location within our configuration for MicroStation. Give it a name out there. I'm just simply going to add a new line style definition by creating a new line style resource library. So in this case, maybe we'll just simply call it barrier for the RSC file's title. And then from there in MicroStation, you can actually name it whatever you want. So we're going to begin by creating the user-friendly name that the person picks from the drop-down list. So in this case, let's do something maybe like slip form barrier, something like that. Then from there, what do you need to make these? And a lot of times people make these more complicated than what they need to. They do multiple point cells, they incorporate multiple stroke patterns, compounds where they don't need to sometimes, things like that. Again, keep it as simple as possible. I'm going to ask myself a question right now. What is it that I'm going to incorporate into this line style? And for myself, this is essentially going to be nothing more than that three-dimensional piece of geometry just used over and over and over again, that single piece of geometry. So I know that's going to end up being a cell. That means I'm going to need a point. Do I need something like a stroke pattern, which was the repetition? Yeah, but we might not need a compound to tie the two together. So, we can kind of take a look at this as we go through it. All right, so let's begin by creating the user-friendly name. We've done that, right? Slip form barrier is good. And then from there, migrating over into the components that actually make up the line style itself. Now, the stroke patterns I've told you is kind of the repetition of this. How often does it repeat? We do that through a stroke pattern definition. And I know that the overall thickness, the horizontal value for the extrusion that we gave it was half of a master unit of measurement. We gave it 6 inches. We're working in US survey feet. So when I come in and add my stroke component, I'm going to go ahead and give it a name. I'm going to go ahead and keep the name the same, just so we know how they correspond to one another. And I'm going to add in a single stroke to this, into the stroke pattern. I'm going to leave this with a fixed length of exactly 0.5 master units. Again, whether that's meters, inches, feet, millimeters, it doesn't matter. It's half of the master unit relative to where it's going to be used at. Now, I'm going to leave this as a gap. I don't need to actually have this draw anything, but instead I'm using it to define a measurement, and that's it right there. All right, so we're done with the stroke part of this. Now I need to build my three-dimensional point cell. We do that not through the cell library, but rather right through here in the line style editor by creating a point. Again, you can name it exactly the same. I can even cheat a little bit and maybe copy and paste that in if I want to. Now I've got my new point here. And when we represent this symbol over and over and over again to create this slip form barrier, how often it repeats, I'm going to use the stroke pattern to help me define. So when I pick the base stroke pattern, I'm going to choose that slip form barrier that I just did. And so the origin point for the cell is going to be right in the center, going to be 6 inches apart from each one of these as we go. Okay, so there's our simple stroke pattern that we just chose. Now, to create the cell itself, it's no different than creating a cell for any other usage in MicroStation. You still have to select the geometry with either the element selection tool or a fence if you would prefer. It's up to you. I have to provide an origin point. And so for me to do that, I'm actually going to run back over here to the drawing tools just so I can show this to you. And in annotation is where we find all of the annotate tools. This includes all of your cell commands as well. And so I can get a hold of my define cell origin right from here. Now, I know the intersection of the two green lines is at the appropriate location where I want the cell's origin point to be. That's why I oriented the geometry relative to it. So I'm going to snap to and place my origin point at that location. Now, I know the display is rendered over here, but if we were to change that over to a wireframe, you can see that is placed at the right location relative to the geometry itself. That's going to get it in the right spot for me. And now I'm ready to come in here and create the point cell. To create the point, we hit create and we simply give it a name. Now this, I will admit, is a little unforgiving here. Once a point has been created and stored in the resource library, it's not just a simple matter of deleting one that you don't want anymore. So this is kind of a one-time thing here for creating this. So you want to make sure you type in the name the way that you wish. Again, I'm going to be pretty simple on this one, though. I'm just going to go ahead and kind of repeat the process and use the same name and then hit OK. Now that creates the point and stores it in the RSC file that we're working in right now. We still haven't told it how to use it yet, but it's stored in the file itself so that we can use it. So now that's where the stroke pattern comes into play. Do you want one of these at the beginning, one at the end? Do you want to place one of these symbols at every one of the vertices on the line? Or would you like to repeat it along the length of the stroke pattern itself? Yes, this horizontal bar right here is actually a button that you can click. Now, you would use origin and end to do a different cell at the beginning and end of the line when the line is created. This is how something like the guardrail is done. In order to place some sort of an end treatment, we would attach a different cell at the origin, a different one at the end, and then maybe do the rail itself and so forth along the length of the stroke pattern in here. Hope that makes sense. So I went ahead and picked the stroke pattern. Now I'm going to hit select. I'm going to pick my point symbol, click OK, and you can see the repetition here as we go. Now remember, this is going to base it upon the center of that as we do this. If you would have rather had this at the very beginning, I could have moved the origin point of the cell over a little bit if I chose to. Now, the only thing is, sometimes by not justifying the cell in the center, it makes that deflection around a curve, that stroking effect, even more pronounced. So in this case, I want to go ahead and offset the beginning point of the line style's 3D geometry representation to the beginning of the line itself, not the center, but the beginning. And so I'm going to actually go ahead and change this just slightly by giving this an offset. So the cell will not begin so that the center of the self is at the end of the line that you use to draw it. I'm actually going to offset that a -3 inches in here so that we have it where we want. So Now, this is done in master units only. So you saw when I tried to type in 3 inches, the :3, for instance, it just blocked it out. It doesn't understand. This is master units only. So it's going to be a 0.25 feet. So it'd be a negative 0.25, something kind of like that. That will essentially move the origin of this over for me automatically. Now, as far as what it looks like, I drew it on a specific level in a particular color and so forth for a reason. I'm going to let it just simply pull the color of the cell, the symbol, so that I don't have to worry about what level it's drawn on and the color of the level. It's always going to show up gray because that's the color that my cell is in. Clip partial. What if you don't run into a full representation of that 6 inches when it hits the end of the line? Do you want to trim it off? I do. I want to project it from the beginning of the cell and clip whatever partial amount of that cell is left over, just clip it away. All right, so we're actually pretty well done here at this point. So now we just simply need to kind of finish up the process by saving what it is that we've done. We are working with a point and a stroke. And I know a lot of folks that have created custom line styles in the past, they would come in here and create a compound and actually list both of those in the compound. We don't need to do that in this case. For something more complex, again, like the guardrail that I showed you, yeah, I probably would have to do that. But for this one, I'm actually going to go ahead and tie the name to the point itself because that's the only component that's truly being drawn by this line style definition. And I do that by linking the name to the component using the link command. And so, folks, we are essentially done at this point with this slip form barrier. The only thing I do need to worry about is unit definitions, and that's an important aspect of this. So line styles by default work with annotation scale. That means if I change the annotation scale to anything other than full size 1:1, the line style is going to scale bigger by the annotation scale factor. And we know that this barrier represents a true real world object at a certain size. And so to keep this from scaling, you'll find that there is a physical setting. Any custom line style that you make physical doesn't scale by the annotation scale setting, for instance. All right, so we just made this one physical. We're good to go at this point, hopefully. So now we can save our work and now actually go try this out then.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.